price increase for installing electrical wiring in electrical metallic tubing, commonly called EMT, compared to Romex, which is non-metallic sheath cable, may vary depending on a number of factors. These factors can include labor costs, the cost of materials themselves, and also the complexity of the installation. However, as a general guideline, it can be expected that there's an increase of approximately 20 to 30% when using EMT instead of Romex. The preference for EMT in certain situations often arises from the increased durability and protection it offers, especially in environments that are considered to be harsh, such as coastal environments or areas near large bodies of water. EMT is more resistant to moisture, corrosion, and physical damage, making it a more robust choice than Romex in those applications. In addition to the base price increase for the EMT materials themselves, there may be additional costs associated with several factors. Firstly, the installation process for EMT is generally more labor-intensive than Romex. Secondly, special fittings and connectors are required for EMT, increasing material costs. Thirdly, ground rods and bonding for electrical grounding may be necessary, adding to the overall cost. Fourthly, permit and inspection fees, if applicable in the area, should also be considered. To provide a more concrete example, if the estimated cost for an electrical installation using Romex is between $20,000 and $25,000, increasing that price by 20 to 30% for EMT would result in a revised price range of $24,000 to $32,500. It's important to obtain accurate measurements and details of the installation before providing a final quote. The number of openings, recess cans, and any other special requirements can significantly affect the overall price. When choosing between the EMT and Romex for electrical wiring, several factors should be considered. Firstly, the environment in which the wiring will be installed. EMT is generally preferred in areas where there is a high risk of moisture, corrosion, or physical damage. Secondly, the budget for the project. EMT is typically more expensive than Romex, so it's important to factor in the cost difference when making a decision. Thirdly, local building codes and regulations. Some jurisdictions may require the use of EMT in certain types of buildings or applications. When installing EMT, it's important to follow proper installation techniques to ensure a safe and reliable electrical system. Firstly, all EMT fittings and connectors should be properly tightened to prevent moisture from entering the conduit. Secondly, EMT should be properly grounded to prevent electrical shock. Thirdly, EMT should be supported properly to prevent sagging or damage. When working with electrical wiring, it's important to take necessary safety precautions to prevent electrical shock or other injuries. Firstly, always turn off the power to the circuit before working on any electrical wiring. Secondly, wear appropriate personal protective equipment such as safety glasses and gloves. Thirdly, use insulated tools when working with electrical wiring. Fourthly, if you're not comfortable working with electrical wiring, it's best to hire a qualified electrician. Let's delve deeper into the specifics of EMT and Romex, starting with EMT, which stands for electrical metallic tubing. EMT is a type of rigid metal conduit that is commonly used to protect electrical wiring. It is typically made of galvanized steel or aluminum and is available in various sizes and thicknesses. EMT is known for its durability and resistance to corrosion, making it a popular choice for both indoor and outdoor applications. One of the main advantages of using EMT is its ability to protect electrical wiring from physical damage. The rigid metal construction of EMT provides a barrier against impacts, abrasions, and other potential hazards. This is particularly important in industrial or commercial settings where wiring may be exposed to heavy machinery or equipment. Another advantage of EMT is its resistance to moisture and corrosion. The galvanized coating on steel EMT or the inherent properties of aluminum EMT help to prevent rust and corrosion, making it suitable for use in damp or wet environments. This is especially important in areas near bodies of water or in locations with high humidity. EMT is also relatively easy to install. It can be cut and bent to fit specific configurations, and various fittings and connectors are available to join sections of EMT together. However, proper installation techniques are essential to ensure that the conduit is properly grounded and that all connections are secure. Now let's turn our attention to Romex, which is a type of non-metallic sheath cable that is commonly used in residential wiring. Romex consists of 2 or more insulated conductors wrapped in a plastic jacket. It is typically less expensive than EMT and is easier to install, making it a popular choice for homeowners and DIY enthusiasts. One of the main advantages of using Romex is its cost-effectiveness. Romex is generally less expensive than EMT, both in terms of materials and labor. This can make it an attractive option for budget-conscious projects. Another advantage of Romex is its ease of installation. Romex can be easily routed through walls and ceilings, and it does not require the use of special tools or fittings. This can save time and effort during the installation process. However, Romex is not as durable or resistant to moisture and corrosion as EMT. The plastic jacket of Romex can be damaged by impacts, abrasions, or exposure to sunlight. It is also not suitable for use in damp or wet environments. Therefore, Romex is typically used in dry, indoor locations where it is not exposed to harsh conditions. In summary, the choice between EMT and Romex depends on the specific application and the environment in which the wiring will be installed. EMT is generally preferred in areas where durability, protection, and resistance to moisture and corrosion are important considerations. Romex is a more cost-effective option for dry, indoor locations where these factors are not as critical. Let's discuss the National Electrical Code, or NEC, which provides guidelines and standards for electrical installations in the United States. The NEC covers a wide range of topics, including wiring methods, grounding, overcurrent protection, and equipment installation. Both EMT and Romex are recognized wiring methods under the NEC, but there are specific requirements for their use. For example, the NEC specifies the types of locations where EMT and Romex can be used, as well as the methods for supporting and securing the wiring. It is important to consult the NEC and local building codes to ensure that all electrical installations comply with applicable regulations. Now let's delve into the practical aspects of estimating the cost of an electrical installation using EMT. As mentioned earlier, the price increase for using EMT compared to Romex can vary depending on several factors. Firstly, the cost of materials. EMT conduit, fittings, and connectors are typically more expensive than Romex cable and related accessories. The specific cost difference will depend on the size and type of EMT used, as well as the quantity required. Secondly, the labor costs. Installing EMT is generally more labor-intensive than installing Romex. This is because EMT requires more precise cutting, bending, and fitting. The additional labor time will translate into higher labor costs for the project. Thirdly, the complexity of the installation. The complexity of the installation can also affect the cost of using EMT. If the wiring needs to be routed through difficult or confined spaces, it may take more time and effort to install EMT. Similarly, if the installation requires a large number of bends or fittings, this will also increase the overall cost. To provide an accurate estimate for an electrical installation using EMT, it is important to carefully assess the project requirements and consider all of the factors mentioned above. This may involve conducting a site visit to evaluate the existing conditions, reviewing the electrical plans, and consulting with a qualified electrician. Once the project requirements are well defined, it is possible to obtain accurate material quotes and labor estimates. It is also important to factor in any permit or inspection fees that may be required by local authorities. By taking a comprehensive approach to estimating the cost of an electrical installation using EMT, it is possible to provide a fair and accurate quote to the customer. Moreover, it is essential to communicate clearly with the customer about the reasons for using EMT and the benefits it provides. This will help to ensure that the customer understands the value of the investment and is satisfied with the final result. Let's move on to discuss grounding and bonding requirements for EMT systems. Grounding and bonding are essential for ensuring the safety and proper operation of electrical systems. Grounding provides a path for fault current to flow back to the source, which helps to trip circuit breakers or fuses and prevent electrical shock. Bonding connects all metal parts of the electrical system together, which helps to equalize voltage and reduce the risk of shock. For EMT systems, grounding is typically achieved by connecting the EMT conduit to the electrical panel using a grounding bushing or connector. The grounding bushing or connector provides a secure connection between the EMT and the grounding conductor, which is typically a bare copper wire. Bonding is achieved by connecting all metal parts of the EMT system together using bonding jumpers or connectors. This includes the EMT conduit, fittings, boxes, and enclosures. The bonding jumpers or connectors ensure that all metal parts are at the same electrical potential, which reduces the risk of shock. The NEC provides detailed requirements for grounding and bonding of EMT systems. It is important to consult the NEC and local building codes to ensure that all grounding and bonding requirements are met. Improper grounding or bonding can create a serious safety hazard and can also interfere with the proper operation of electrical equipment. Now, let's explore some common applications of EMT in residential and commercial buildings. EMT is commonly used in a variety of applications, including lighting, power distribution, and control systems. In residential buildings, EMT is often used for wiring in unfinished basements, garages, and outdoor areas. It is also used for wiring in kitchens and bathrooms where there is a higher risk of moisture. In commercial buildings, EMT is often used for wiring in offices, retail spaces, and industrial facilities. It is also used for wiring in hazardous locations where there is a risk of explosion or fire. EMT is a versatile wiring method that can be used in a wide range of applications. Its durability, protection, and resistance to moisture and corrosion make it a popular choice for both residential and commercial buildings. Let's discuss some tips for working with EMT. Working with EMT can be challenging, but with the right tools and techniques, it can be done safely and efficiently. Firstly, use the right tools. There are a variety of specialized tools available for cutting, bending, and threading EMT. Using the right tools will make the job easier and will also help to ensure that the EMT is properly installed. Secondly, measure accurately. Before cutting or bending EMT, it is important to measure accurately. This will help to ensure that the EMT fits properly and that there are no gaps or misalignment. Thirdly, bend carefully. Bending EMT requires skill and practice. It is important to use the right bending techniques and to avoid kinking or damaging the EMT. Fourthly, thread properly. Threading EMT is necessary for making connections to fittings and boxes. It is important to use the right threading tools and to ensure that the threads are clean and properly aligned. Fifthly, support properly. EMT must be properly supported to prevent sagging or damage. Use appropriate supports and hangers to secure the EMT to the building structure. By following these tips, you can work with EMT safely and efficiently and can ensure that the electrical system is properly installed. Now, let's delve into the topic of cost-saving measures when using EMT. While EMT is generally more expensive than Romex, there are some steps that can be taken to minimize the costs. Firstly, optimize the layout. Careful planning of the electrical layout can help to minimize the amount of EMT required. This can involve consolidating circuits, using shorter runs of EMT, and avoiding unnecessary bends. Secondly, use the right size of EMT. Using the appropriate size of EMT can help to reduce material costs. Avoid using larger sizes of EMT than are necessary. Thirdly, purchase materials in bulk. Purchasing EMT, fittings, and connectors in bulk can often result in significant cost savings. Fourthly, negotiate with suppliers. Don't be afraid to negotiate with suppliers to get the best possible price on materials. Fifthly, consider alternative wiring methods. In some cases, it may be possible to use a combination of EMT and other wiring methods to reduce the overall cost. However, it is important to ensure that all wiring methods comply with applicable codes and regulations. By implementing these cost-saving measures, it is possible to reduce the overall cost of using EMT without compromising safety or quality. Remember that careful planning and attention to detail are key to successful and cost-effective electrical installations. Let's shift our focus to the environmental considerations associated with using EMT and Romex. Both EMT and Romex have environmental impacts, but they differ in the nature and magnitude. EMT is typically made of steel or aluminum, which are recyclable materials. Recycling EMT can help to conserve resources and reduce the amount of waste sent to landfills. However, the manufacturing process for EMT can be energy intensive and can generate pollution. Romex is made of plastic, which is not as easily recyclable as metal. The manufacturing process for Romex can also generate pollution and can contribute to the depletion of fossil fuels. When choosing between EMT and Romex, it is important to consider the environmental impacts of each material. In general, EMT is considered to be more environmentally friendly than Romex due to its recyclability. However, it is important to weigh the environmental benefits of EMT against the cost and performance considerations. Now, let's discuss the safety aspects of using EMT and Romex. Safety is a paramount concern when working with electrical wiring. Both EMT and Romex can be used safely, but it is important to follow proper installation techniques and to take necessary precautions. EMT provides a high level of physical protection for electrical wiring. The rigid metal conduit can help to protect the wiring from damage caused by impacts, abrasions, or other hazards. EMT is also resistant to moisture and corrosion, which can help to prevent electrical shorts and fires. Romex provides less physical protection than EMT. The plastic jacket of Romex can be damaged by impacts, abrasions, or exposure to sunlight. Romex is also not as resistant to moisture and corrosion as EMT. When using Romex, it is important to protect the wiring from damage and to avoid using it in damp or wet locations. Regardless of which wiring method is used, it is essential to follow proper installation techniques and to take necessary safety precautions. This includes turning off the power before working on any electrical wiring, wearing appropriate personal protective equipment, and using insulated tools. Let's explore the topic of future trends in electrical wiring. The electrical industry is constantly evolving, and new technologies and materials are being developed all the time. Some of the key trends in electrical wiring include the increasing use of smart home technology, the growing demand for energy-efficient wiring solutions, and the development of new and improved wiring materials. Smart home technology is becoming increasingly popular, and this is driving demand for electrical wiring that can support advanced features such as remote control, automation, and energy monitoring. Energy-efficient wiring solutions are also in high demand as homeowners and businesses seek to reduce their energy consumption and lower their utility bills. New and improved wiring materials are being developed that offer improved performance, durability, and safety. These materials include new types of insulation, conductors, and conduit. As the electrical industry continues to evolve, it is important to stay up to date on the latest trends and technologies. This will help to ensure that electrical installations are safe, efficient, and reliable. Now let's delve into the topic of troubleshooting common problems with EMT and Romex wiring. Electrical problems can occur with both EMT and Romex wiring systems. It is important to be able to troubleshoot these problems safely and effectively. Some common problems with EMT wiring include loose connections, corroded conduit, and damaged wiring. Loose connections can cause arcing, overheating, and even fires. Corroded conduit can reduce the effectiveness of grounding and can also damage the wiring. Damaged wiring can cause shorts, open circuits, and electrical shock hazards. Some common problems with Romex wiring include damaged insulation, loose connections, and improper installation. Damaged insulation can expose the conductors and create a shock hazard. Loose connections can cause arcing, overheating, and fires. Improper installation can violate electrical codes and can create safety hazards. When troubleshooting electrical problems, it is important to follow proper safety procedures and to use appropriate test equipment. This includes turning off the power before working on any wiring, wearing appropriate personal protective equipment, and using a multimeter to check for voltage and continuity. Let's turn our attention to the importance of proper documentation for electrical installations. Proper documentation is essential for ensuring the safety, reliability, and maintainability of electrical systems. Documentation should include detailed drawings, specifications, and records of all electrical work performed. Drawings should show the layout of the electrical system, including the location of wiring, equipment, and devices. Specifications should describe the materials used, the installation methods followed, and the testing performed. Records should document all electrical work performed, including the date, the name of the electrician, and a description of the work. Proper documentation is essential for troubleshooting problems, making repairs, and performing upgrades. It is also essential for complying with electrical codes and regulations. In addition to creating documentation, it is also important to store it in a safe and accessible location. This will ensure that the documentation is available when it is needed. Let's address some frequently asked questions about EMT and Romex wiring. Firstly, what are the main differences between EMT and Romex? EMT is a rigid metal conduit, while Romex is a non-metallic sheet cable. EMT provides more physical protection and is more resistant to moisture and corrosion, while Romex is less expensive and easier to install. Secondly, where is EMT typically used? EMT is typically used in areas where there is a high risk of physical damage, moisture, or corrosion, such as unfinished basements, garages, and outdoor areas. Thirdly, where is Romex typically used? Romex is typically used in dry, indoor locations where there is less risk of physical damage, moisture, or corrosion, such as living rooms, bedrooms, and hallways. Fourthly, is EMT more expensive than Romex? Yes, EMT is generally more expensive than Romex. Fifthly, is EMT harder to install than Romex? Yes, EMT is generally harder to install than Romex. Sixthly, which wiring method is safer, EMT or Romex? Both EMT and Romex can be used safely, but it is important to follow proper installation techniques and to take necessary precautions. EMT provides more physical protection and is more resistant to moisture and corrosion, which can reduce the risk of electrical shorts and fires. By addressing these frequently asked questions, it is possible to provide a clearer understanding of the differences between EMT and Romex wiring and to help people make informed decisions about which wiring method is best for their needs.